So hello everyone, I Raghavendra Singh welcomes you all in this channel. So actually, I have written this already, but uh, I was checking that video was not recording. So I have written this, nothing else. I have discussed. So right now I'm going to discuss about even function and odd function. Okay, I hope it is all visible. Yeah, yes. So even function and odd function. So so even function. What are the even functions? For example, even function. I will also discuss the formula, but if anywhere we get cos x, sec x, and x square, so these are what? These are even function. We are, uh, if we get x cube, sin x, and cosec x, so these are what? These are odd function. Remember this. Why I am telling you what is even function, what is odd function? I will discuss about it after. Okay. So, and second thing, if f of minus x we get only f of x, then also we can say it is even. Okay, sometimes actually what will happen, that sometimes we will not get very simple, that cos x and sec x. Sometimes we will get uh, or sometimes we will get any integer value, so we need to put it minus x, then what we will get, that is there is something how we will decide. Okay, and now another one, if we are putting minus x and we are getting f of minus x, so this is what, this is odd function. Okay, yes, this is odd function. So now one more thing which we need to remember is, if integration minus a to a f of x dx. Okay, now if f of x, remember, if f of x is even, then what we will do, this is, we can say, we can remember, then here will be 2 0 to a limit and f of x dx. This is what which we will do if it is even, only for even. And what if it is odd? If it is odd, then it is directly 0. We do not need to solve it. If it is odd, then we can simply put it 0. Okay, so now formula, I hope this is all very clearly visible. So now formula is e to the power ax dot sin bx dx is equal to integration of e to the power ax sin bx dx is equal to e to the power ax upon a square plus b square in bracket a sin bx minus b cos bx. I hope this is all visible. I will explain it about like what is this, but after some time. And now second formula is e to the power ax cos bx gx is equal to e to the power ax a square plus b square a cos bx plus b sin bx. Okay, this is the formula. These are the two formulas for sin x and cos x which we need to remember. Okay, and some more thing which we need to remember, that is sin n pi. If we will get sin n pi, then what is, it will be always 0. Okay, sin n pi will be always 0. And sin 2n pi will be also always 0. Okay, and cos n pi is equal to always minus 1 to the power n. Okay, remember this, cos n pi we will use it multiple of times. Okay, cos n pi is equal to minus 1 to the power n. Cos 2n pi is equal to 1. Also you need to remember this. So these are some properties we can say, so which we need to remember. So now let's move on to the Fourier coefficient. First of all, let's discuss what is Fourier series. Fourier series. Okay. So basically, Fourier series is, yes. So Fourier series is f of x is equal to a naught plus summation of n is equal to 1 to infinity. Okay, n is equal to 1 to infinity a n cos nx. Okay, n cos nx, yes, only cos nx, plus summation of n is equal to 1 to infinity bn sin nx. Okay, so this is the Fourier series. Okay, so this is the Fourier series. Yes. And how we will find a naught, an and bn? Now for a naught, what is the formula of a naught? And uh, I will also discuss about question, but let me discuss how question will look. Simply question will be given in a form of series. We need to find a naught, then an, then bn, and then question will say that if you have to find the Fourier series, then we will put in this Fourier series. Also, so this is question number 1. So what is the formula of a naught? A naught formula is 1 upon 2 pi 1 upon 2 pi 1 upon 2 pi integration of fx dx. I'm here getting confused on limits. I think here should be limit 0 to pi. I think, let me check it. What should be limit? Limits is 0 to 2 pi. Limit is 0 to 2 pi. Zero to 2 pi. Okay, and formula of an in an is equal to 1 upon pi integration of 0 to 2 pi 0 to 2 pi f of x cos nx dot dx. Formula of bn is equal to 1 upon pi 0 to 2 pi f of x sin nx dot dx. Okay, so these are the formulas. Means this all page is very important. I will just suggest you take a screenshot and remember all of this. Like, let me recall what I did is simply first of all I discussed about odd and even function. Then I told you that how we will decide if it is odd or if it is even, and what we will do if it is even, and what we will do if it is odd. Then these are some formulas which you need to remember, and then simply these are some properties which you need to remember. And this is Fourier series, and I have also discussed how we will find an, a naught, and bn. Okay, yes. So let's move on to the next page. So here there are mainly three types of Fourier series. So which I told you already that what are the four types of Fourier series. This is all about intervals. Like, first of all we will find Fourier series in the interval of, I can say, type 1. Fourier series in the interval of 0 to 2 pi. Okay, in the interval of 0 to pi. So let's take a question number 1. What is question number 1 is find Fourier series to represent find Fourier series to represent f of x is equal to x square in 0 comma 2 pi. Again, this in question this interval will be always mentioned, which interval we have to find. Although if interval will be changed, then whole method will be changed. I will discuss about each method, like I will discuss about separate intervals, so I will discuss about it, and hence prove that pi square upon 12 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square. Oh, sorry, here is 1 minus alternative signs, minus 1 upon 4 square. Okay, yes. So as we have given solution, okay, we have given f of x is equal to x square, interval is 0 comma 2 pi. Got it? So what can we do here? I think I need to increase speed so that I can cover it as soon as possible. So although it is very lengthy question, I'm just trying to solve it. So we know the Fourier series. For Fourier series, what we need to do, first of all we need to find the a naught. Okay, so what is formula of finding a naught? Formula of finding a naught is 1 upon 2 pi integration 0 to 2 pi f of x. What is f of x? X square into dx. Okay, so let's find it. 1 upon 2 pi integration of x square is x cube upon 3, 0 to 2 pi. Let's put 2 pi in place of x. I'm just putting upper limit minus lower limit. So 1 upon 2 pi into 8 pi cube upon 3. 8 pi cube upon 3. Okay, 2 चौको 8 and pi square. So here is a naught is equal to 4 pi square upon 3. Okay, a naught is equal to 4 pi square upon 3. So now let's find an. What is formula of an? Formula 1 upon pi integration of 0 to 2 pi f of x cos nx dot dx. So what is f of x? So basically f of x is x square, as I have told you. So just put it. An is equal to 1 upon pi 0 to 2 pi x square cos nx dot dx. Okay, cos nx, this is nx. Now here what we will do, we have to integrate then, but here is we will follow u into v rule. How we will decide first function, second function? Islet. Okay, islet, inverse, logarithmic, algebraic, trigonometric, and or each I think exponential. Yeah. So here is inverse, logarithmic, algebraic. This is algebraic. So this is first function u into v. So we know the formula of integration of u into v dot dx. So in 12th class, what we were used to do is, as I can remember, that integration of first as it is, integration of second means v dot dx minus whole integration, differentiation of first means u differentiation of first into integration of second means this. Okay, so this is what which we were used to do. Now the now we can use also, in place of this we can use u v1 मतलब differentiation minus u differentiation v2 plus u double dash v3 minus v u triple dash means triple times differentiation v4. Okay, we can use this in place of this formula. So I hope that you all know how to find how to apply a Euler rule, how to apply a product rule. So I'm just directly writing the result. Okay, so an is equal to differentiation of this and this 1 upon pi x square as it is differentiation of second, also integration of second cos x minus sin x only sin nx upon n, as you know n is constant, upon n minus now x square is 2x and this as it is minus cos x nx cos nx cos nx upon n square. Okay, plus 2 minus sin nx upon n cube as according to this formula. Okay, so now put the limit from 0 to 2 pi. Now as I told you in the property that if we will put here 2 pi, then what will be here 2 sin n pi. So what was the property? So as you can see here, it is property sin 2 n pi, it is 0. Okay, yes, so here this whole equation will be what 0. Same thing here also, this also will be 0. So we need to put limit on this only. So n is equal to 1 upon pi 2x minus 2x yes, so minus 2 into 2 pi. Okay, this as you can see minus plus and cos n pi, cos 2 n pi and cos 2 n pi this whole equation. So cos 2 n pi only, so this is only cos 2 n pi upon n square 0. So as you know that cos 2 n pi is here in the property, cos 2 n pi is 1, so this will be 1, this only will be 1. So an is equal to 1 upon pi this 2 into 2 upon n square, right? Yes, 1 upon pi 2 into n square. So this 2 is also, so 4 upon n square, right? 4 upon n square. So 1 second, 4 pi, this pi, 4 pi, so this pi to pi cancel, so it is only an is equal to 4 upon n square. Now process to find bn. We have find it a naught, an, now bn. What was the formula bn? 1 upon pi 0 to 2 pi f of x sin nx dot dx. Okay, so let's begin. So what is fx? 1 upon pi 0 to 2 pi x square dot sin nx dot dx. Again here v rule, product rule, I'm just directly writing as you all know the formula. So 1 upon pi integration of this will be x square will be as it is, x square will be as it is, x square will be as it is, sin x का minus cos n x upon n. I'm just directly writing, okay, 2x minus sin n x upon n square plus 2 cos nx upon n cube, limit 0 to 2 pi. Again here as you can see, here in place of x we will put 2 pi, so cos 2n pi, this is again 1, right? And here again sin 2n pi, this is again 0, this is again 0. Here this will be what? This will be again 1. Okay, so yes, so 2n pi, 2 pi square, 4 pi square, so 1 upon pi 4 pi square minus 4 pi square upon n plus 2n pi plus this is 0, so plus 2 upon n cube plus 2 upon n cube plus 2 upon n cube plus 2 upon n cube. Now this was the just upper limit, now minus lower limit. Remember here cos, here is cos, means we will put here is x, we will put 0, this will be whole term 0, but here if we will put 0 this will be also 0, but here we will put 0, cos 0 1, so 2 upon n cube minus 2 upon n cube. Remember this, yeah, this is the main point where we maybe get very confused. So I will just suggest keep always mind very active, keep mind always very active because if you are doing any kind of mistake then the whole answer will be correct. As you can see, plus 2 upon n cube minus 2 upon n cube, this to this cancel, and now pi to pi cancel, so the bn is equal to minus 4 pi upon n. I hope this is all visible. Yeah, yes. So now put it in Fourier series. So now final step is now put all values. What are the all values? A0, an and bn in Fourier series. Okay, put all values in Fourier series. So what was the Fourier series? F of x is equal to a0 plus summation of n is equal to 1 to infinity f of x cos nx plus summation of n is equal to 1 to infinity f of x sin nx. Okay, yes, f of x sin nx. I hope this all will be visible. So what is the value of a0, which we have find? A0 value is this, an value is this, bn value is this. Yes, so here what was fx? Fx was x square is equal to a0. A0 is 4 pi square upon 3 plus summation of n is equal to 1 to infinity fx is x square. Oh, sorry, here it is actually an, it was my mistake, it is an. Okay, an and bn. वही है कि formula sometimes we forget. So here it is an value is 4 upon n square. 4 upon n square cos nx as it is plus summation of n is equal to 1 to infinity bn minus 4 pi upon n sin nx. Okay, yes, so this is the Fourier series. If in questions it is asked that you have to find Fourier series, then it is okay. This is the final answer. Now as we can see in our question that we have to also prove it. Okay, we have to also prove this one. So let's see the proof. We have to prove that thing. So I think I do not need to discuss it. Let me discuss here it only. As this we have to prove means pi square upon 12. So pi square upon 12 we have to prove. So simple x is equal to pi. If we will put, then we will get this prove it thing. Okay, so now let's move on to the next question. As I told you, these are very lengthy question, almost 10 to 12 minutes it is minimum. So now take the next question. Again, I'm just taking the next question. Question number 2, obtain the Fourier series. Obtain the Fourier series. Obtain the Fourier series. Expansion of fx. Expansion of fx is equal to pi minus x upon 2 whole square in the interval 0 is less than x is less than 2 pi, and prove that what we have to prove that pi square upon 6 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square and this. Okay, this is what we have to prove. So again, what we have to given is that is fx is equal to this. For Fourier series, what we need to do is, first of all, we need to find a naught. A naught formula is 1 upon 2 pi 0 to 2 pi f of x dx. So 1 upon 2 pi 0 to 2 pi f of x is this one. F of x is this. So pi minus x upon 2 whole square dot dx. So what is integration of this? 1 upon 2 pi minus x whole cube upon 2 2s are 4. Okay, 0 to 2 pi. So 4 can be taken outside, so 1 upon 8 pi. So pi minus pi minus 2 pi whole cube. So pi minus 2 pi is minus pi only. So 1 upon 8 pi into minus pi whole cube. So pi to pi cancel, means it is actually minus pi square upon 8. Okay. Pi square upon 8, is this correct or not? Yeah, so this is value of a naught. According to me, I think I'm doing some mistake. I don't know what is that mistake. Integration we have done it rightly. Here maybe the problem integration, although this is a naught. Then in the same way we have to find an, which I have told you formula, then bn, then put on equation Fourier series equation. Okay, Fourier series, and then simply put the value and we can prove it. Now let's move on to the next question. Now next question, we can change the interval. Okay, so now interval is Fourier series in the interval of minus pi to pi. Okay, yes. So let's take question number 1. All process will be same, just this only. F of x is equal to minus pi is less than x is less than 0, x 0 is less than x is less than pi. State the value of fx. Value of fx at x is equal to 0, and prove that summation of n is equal to 1 to infinity 1 upon 2 and minus 1 square is equal to pi square upon 8. Okay, yeah. So let's begin. We know the Fourier series. For Fourier series, what we need to do is, firstly, we need to write the Fourier series, then find the a0. So what is a0? 1 upon 2 pi integration of now here is one catch. Now as we can see that this interval has been changed. So minus pi to pi, remember, suppose this is numbering system. Okay, this is numbering system. So here this is minus pi, this is 0, and this is pi. Okay, we cannot directly integrate minus pi to pi. We have to divide it in two parts. So minus pi to 0, then 0 to pi. So minus pi to 0 fx. What is fx? Here we can see that if x is greater than minus pi or less than 0, so fx will be minus pi into dx plus integration of 0 to pi. Okay, I hope you all have understood what I did is. So now here 0 to pi, so it is x dot dx. Okay, yes, x dot dx. Now simply integrate. A0 is equal to 1 upon 2 pi. This is like this. Okay, because 1 upon 2 pi is everywhere. So 1 upon 2 pi minus pi x minus pi to 0 plus x square by 2 0 to pi. Okay, now here I can put the limit minus 0, so this all will be 0, and if I am putting pi, then minus pi square minus pi square plus pi square, it will be plus pi square plus pi square by 2, right? Pi square by 2 minus 0 by 2 doesn't mean. So here I can write 2 pi square plus pi square, 3 pi square by 2 into 1 upon 2 pi. Okay, this to this cancel, and 3 pi by 4. Did I any mistake? According to me, it should be 3 pi by 4. Let me check if I did any mistake. Here in the sign only I did something. So pi square upon 2, this will be as it is pi square upon 2. Pi square upon 2. Here 0, this is 0, doesn't mean to write. And 0 minus minus is already there. Okay, so this will be minus. Okay, so this will be minus. So if this will be minus, then 2 pi square minus 2 pi square, so minus pi square by 2. So minus pi square by 2 only. So this will be minus 1 upon 2 pi minus pi square by 2 only. Okay, so this to this cancel, then only minus pi by 4. So a naught is equal to minus pi by 4. Now an is equal to, same process we will follow again. If now it will be very lengthy just because of here we have to write two times product rule. Let me tell you what I am trying to say. 1 upon pi I hope this is all visible. Yeah, so an is equal to 1 upon pi, again minus pi to 0, f of x. What is f of x? In this limit it is minus pi cos nx, right? Cos nx plus, this is all 0, plus integration of 0 to pi x sin nx dot dx, also dot dx. So what I was trying to say is, you can see here only we have to do nothing. Here we have to follow u into v rule. Okay, u into v rule. So I'm just writing. So an is equal to 1 upon pi cos nx minus pi sin nx upon n minus pi to 0 plus x sin x upon n plus x. Now this thing, x as this sin x and x upon n. Again I did some mistake. It is actually an only. Okay, an में what we will put in an? Cos nx. Okay, cos nx. I was thinking it is bn. No. Cos nx. So what is differentiation of cos nx? Minus cos nx sin nx. Okay, keep in mind it. Minus x, differentiation of x 1 minus cos nx as it is upon n square. Now again differentiation of 1 will be 0. So 0 to pi limit. Okay, so 1 upon pi is in everywhere. So now put sin n pi. What will be here? Sin 0 will be 0 minus sin n pi. Okay, sin n pi will be also 0. So this is 0, doesn't mean to write, plus. Now here sin n pi again 0. Again sin n pi, this will be 0. Okay, so plus 0 minus. Now cos n pi, as I told you, what is cos n pi? Cos n pi is minus 1 to the power n. Minus 1 to the power n. Cos n pi is minus 1 to the power n upon n square minus 1 upon n square minus 1 upon n square. How minus 1 upon n square? Just because of pi we have put cos and pi, then cos 0 is 1, so 1 upon n square. So I can write minus 1 1, as you can see denominator is same, then I can write then I can write 1 upon pi 1 upon pi minus 1 to the power n minus 1 upon n square. This is equal to an. Okay, this is equal to an. Now bn, as we know, for bn 1 upon pi 0 to according to limit, so I can write according to limit. What should I write? Like here we will split it, so I can write c plus 2 pi cos nx cos, not cos nx, for bn fx sin nx dx. Okay, so let's put it on this formula. So according to formula, bn is equal to 1 upon pi, limit first minus pi to 0, then limit for this pi into sin nx, sin nx dot dx, plus this is limit is something like this, plus limit 0 to pi x sin nx dot dx. Now again here u into v rule. Okay, here simple integration 1 upon pi minus pi to 1 upon n minus plus pi minus 1 की पावर n upon n here I have put the limit. Okay, after putting the limit I will get this, and 1 upon pi minus 1 into n upon n or this can be written as bn is equal to 1 upon n 1 minus 2 minus 1 upon n. After some modification we can write this in terms of bn. Now simple now Fourier series. So what is Fourier series? Is f of x a naught plus summation of n is equal to 1 to infinity an cos nx plus n is equal to 1 to infinity bn sin nx. bn sin nx. So now put all values. Fx was what was fx? Fx was different. So what should I put? Fx was minus pi and x, minus pi for limit 0 to minus pi and this was x is equal to a naught. A naught is pi by 4 plus 1 upon pi summation of n is equal to 1 to infinity minus 1 to n minus 1 upon n an into cos nx plus 1 upon pi summation of n is equal to 1 to infinity 1 minus 2 minus 1 की power n upon n. So this is where I have put the value. Now let's discuss about even and odd function. Discuss about even and odd function. Which I have told you already, even and odd function. What is even and odd function? Suppose we have fx is equal to x square, which I have told you x square is even function. How this will be even function? I have put it in place of x minus x. I am also putting here minus x. So this is what? Minus x square plus x square. So what was plus x square was fx. So f of minus x is equal to fx. That's why this is even. An odd function which I have told you already. So here are some things which we have to remember. If we are getting what? We are getting even. If we are getting even, then integration of 0 to pi fx dx simply multiplied by 2. If odd we are getting, then simple difference integration will be 0, which I have told you already. Suppose odd function, if it is given integration minus pi to pi f of x sin nx dx is 0, just because of odd function. Okay, odd function. Let's discuss the question. So main concept is agar, you can say if bn is even, then starting means 2, that is a naught and an will be always 0, we do not need to find that. If in starting it is even, then bn will be always 0. Remember this, okay? Yes. So now question. Recording, I think it is almost 49 minutes. I hope this is all visible. Find the Fourier series. Find the Fourier series for fx equal to x, and condition is minus pi less than equal to x is less than equal to pi. This is the condition. First of all, check odd or even. So what we will do, we will check odd or even. So for check odd or even, what we used to do is f in place of x we will put minus x, and then here we will also minus x, and here in x what was it was f of x, so f of x minus f of x. So what is this? This is even. So what they will here is negative, so it is an odd function. Okay, it is an odd function, means a naught odd function means a naught and an will be 0. Will not need to find here, only bn. This is which I mean. Okay, I hope you all have understood right now. Yes. So for formula bn is 1 upon pi integration of f of x 1 upon pi integration of f of x sin nx dot dx. So 1 upon pi formula is here 2 upon pi. Here, as I told you, we have to remember it will be 2 upon pi. 2 upon pi 0 to infinity, 0 to pi x fx sin nx dot dx. Now you want to v rule, product rule. Okay, so 2 upon pi x into cos nx upon n minus 1 sin nx upon n square 0 to pi. Now simply upper limit minus lower limit, so 2 upon pi, we're directly putting it. After putting upper limit minus lower limit, we will get minus 1 n upon n, it's pi to pi. So bn is equal to 2 minus 1 into minus 1 into n. I hope you all have understood why I write like this, just because here this can be written as n plus 1. So 2 minus 1 n plus 1 upon n, yeah, this is equal to bn. Now simply write the Fourier series. Write the Fourier series. Okay. Now another question we can also check. Now there is just same as this, so I'm not discussing all this. Now interval will be again changed, then here will be now uh, minus pi to here will be now pi to 0 to pi. Now I'm just directly discussing a half range series. So half range series means first of all here will be cosine series, cosine, and here will be sine. So for cosine series, a naught is equal to 1 upon L 0 to L f of x dx. Okay, and for sine, bn is equal to 2 upon L 0 to L f of x sine and pi x dx upon L. Here only if there is sine, then we need to find bn only, and here also an. For an it is 2 upon L 0 to L f of x cos and pi x upon L to dx. Okay, yeah. So now let's take example or question number 1. Question number 1, find cosine series of period. Find cosine series of period. Find cosine series of period 2 pi to 2 pi to represent sin x in the interval is this. Okay, let me drink water. Yes, so here as it is mentioned that is cosine series, means we have to find a naught and an. Okay, and here is this 0 to pi, means here L is equal to pi. We will replace the limit by this one. So for formula, a naught is equal to 1 upon L 0 to L fx dx. Okay, so here 1 upon L is 1 upon pi 0 to pi fx is sin x dot dx. So integration of sin x is minus cos x 0 to pi 1 upon pi. So cos pi is minus 1, right? Minus 1 plus 1. So 1 upon pi minus cos pi minus cos 0. Okay, so this is cos pi is minus 1 and this is minus 1, so minus 2. So minus 2 upon pi is equal to a naught. Minus 2 upon pi is equal to a naught. Okay, now an for an formula is 2 upon L integration of 0 to L f of x cos and pi x upon L dx. Okay, yes. So here as we can see lot of things. Here L, this can be replaced as pi, so pi to pi can be cancelled. Here also 2 upon pi, so 2 upon pi 0 to pi f of x is sin nx, sorry sin x only, sin x into cos x cos nx dot dx, cos nx dot dx. Here sin a into sin b. So if 2 I can if I take 2 inside, then 2 sin a to cos b. Formula is 2 sin a cos b is sin a plus b plus sin a minus b, sin a minus b. So I always recommend you that always keep in mind the formula of trigonometry. It can be used anywhere. Okay, so if here will be 2 cos a cos b, that simple it will be formula. So here sin a plus b, this is a, this is b, and x. Okay, so 1 upon pi only now here, 0 to pi sin a plus b, a x plus nx plus cos sin a minus b plus sin a minus b, sin a minus b, x minus nx, x minus nx dx. Now I can integrate it all just separate. 1 upon pi and I can write it 0 to pi, 1 upon pi 0 to pi sin nx sin 1 plus n x. Now this is separate, 0 to pi sin 1 minus n x dot dx. Now simply integrate it. So 1 upon pi sin 1 plus n minus cos n plus 1 upon n plus 1 x plus cos n minus 1 x upon n minus 1, 0 to pi. Now just put the value. So again cos and pi here will be, so I'm just writing the direct answer. So 1 upon pi cos of n pi plus 1 upon n plus 1 minus 1 upon n minus 1. So cos n pi is minus 1 to the power n. So 1 upon pi minus 1 to the power n plus 1. This and plus this and a square minus b square, a square minus b square. So this to this multiply again. So here 1 an is equal to minus 2 upon pi n square minus 1 x 1 plus minus 1 n. Okay, so this is an. Now simply put on cosine series, but as cosine series simply fx is equal to an plus integration of an and pi lx upon l. So what I did basically here, as you all have seen. Okay, so there is another example. Now same thing I can do with sine series also. I hope you all have understood. So thanks for watching. Now another concept is, that is I don't think it is in syllabus, Parseval's identity. So basically partial Euler's identity is 1 upon 2l c to c plus 2l f of x square dot dx is equal to a naught square plus 1 upon n summation n is equal to 1 to infinity a n square plus b n square. And we know the formula of a n and b n. And just thanks for watching now. Thanks for watching. I hope this video will be helpful for all of you. This side Raghavendra Singh.